Hi, welcome back to the channel. In today's lesson, we'll see minor, cofactors, and adjoints of a matrix. In our last lesson, we saw the determinant of the 2 by 2 matrix and also the 3 by 3 matrix. In this lesson, we'll apply the basic concept of the determinant of the 2 by 2 matrix. So in case you missed that lesson, please do not hesitate to check the description below. That said, let's get into class. Let's say we have a matrix. We have a matrix A. Now the minor of this matrix, we can find the minor of each element of this matrix. Now the minor of the element A11 will be, we remove the column, the row associated with A11. Then I'll be left with A22, A23, A32, and A33. So that the minor, let's call the minor of A11, A11 will be the determinant of A22, A23, A32, A33. Also, let's look for the minor of A23. Now, if you look at A23, A23 is on the third row, on the third column. Here's the third column here. A23 is on the third column. Here's the third column here. Let's highlight it. And also on the second row. So that the items I have left out are A11, A12, A31, and A32. So the minor, I write the minor of A23 as M23 will now be equals to, that will be the determinant of A11, A12, A31, and A32. Now I can easily write this to be A11 times A32 minus A12 times A31. Let's take a vivid example. Now, in this matrix, if I'm to look for the minor of probably the element 4 on the second row and on the first column. Now, I can pick my first row, my first column, where 4 falls in, and the second row. So I have these elements outstanding. I have so that A4 now will actually come from the determinant of 3, 5, 4, and 0. So that will be 3 times 0, that's equals to 3 times 0 minus 4 times 5. So that this is equals to 0 minus 20, which is equals to minus 20. Now, if I'm to take, let's look for the minor of 0 now. Now for the minor of 0, 0 is on the third column and on the third row. Here is 0. Such that what I have outstanding with 2, 3, 4, and 1. So that the minor of 0 now will come from 2, as the determinant of 2, 3, 4, and 1, which is equals to 2 times 1 minus 3 times 4. That's equals to 2 minus 12, which is equals to minus 10. Now we have seen how to find the minor of a matrix. Another closely related concept to the minor of a matrix is the cofactor of a matrix. Now let's see how to find the cofactor of a matrix. We'll still use the same set of examples. Now, like we did our matrix A. Now, if I'm to find the cofactor of this matrix A, the first thing I'll do is to attach signs to the matrix A. The signs are very easy. Start with the first element in the matrix. The first element in the matrix will have a positive sign. The next element will have a negative sign. The next will have a positive sign. That's on the rows. Now along the column, since the first has a positive sign here, the next will have a negative sign and a positive sign. Obviously, along this row, the second row, the first element here has a negative sign. Here I'll have a positive sign, here a negative, here a negative sign, here a positive. So that the cofactor of each element of this matrix is the sign attached to this matrix alongside its minor. How do I mean? Remember we said that if for this element A1, the minor of A1, A11 is equals to, we repeat the column and the row is equals to the elements, the determinant of the elements outside A11's row and column. That's A22, A23, A32, and A33. When I find this determinant, the cofactor of A11 will actually be equals to the positive sign alongside the minor A11. So that this, if my determinant here is equals to A22, A23 minus A32, sorry, this is A33, not A23, A32, A23. Then the cofactor also will be the same thing as plus into A22, A23, A33 minus A32, A23. Let's find the cofactor of this element A32. Now for A32, you observe that this is A32 belongs to the second column and the third row. So that for my minor, the first thing is to pick the minor. MA32 will be the same thing as the elements outside that minor, A11, A21, A13, A23. So that the determinant of this element is equals to A11, A23 minus A13, A21. Now, the cofactor of this element A32 obviously will now be, I'll pick the sign here, it's negative sign. I'll pick this sign, be minus into A11, A23 minus A13, A21. Now let's solve an example. Let's solve an example to further understand how to use cofactor of a matrix. Now let's find the cofactor of elements. We're going to look for the cofactor of 7, 8, and 9. Now you see that 7, let's attach a sign first. This is positive. The first will be positive, like I said. Here is minus. Here is positive. This will be minus. Here will be positive. Here will be minus. Here is positive. Here is minus. And here also is what? Positive. Now, the cofactor, to find the cofactor for 7, I'll be interested in the minor first. Let's see what M7 will look like. The minor for 7, if you pick the column around 7, and you pick the rows, so we'll be left with 5, 8, 4, and 9. So that the determinant of this will come from 5 times 9, that's 45, minus 4 times 8, that's 32. So that 45 minus 32, that equals to 13. So that the cofactor C7, I'll attach the positive sign to it, is positive 13, which is the same thing as 13. Let's look for the cofactor of 5. 8. 8, that's the next. The sign along it is negative, and 8 is on the last row but on the second column. So that C8 will now come from, let's attach the negative sign straight to the determinant of 7, 6, 2, minus 2, sorry, that's minus 2, and 4. That's equals to minus into 7 times 4, that's 28, minus 2, minus 2 times 6, that's minus 12. That's equals to minus into 28 plus 12. Obviously, that's equals to minus 40. Now, let's look for the cofactor of 9. C9 come from 9 is positive, the sign on that is positive. Then if you look at it again, here's a column and also here's a row for 9. Here's a column. So the elements out, I have 7, 1, 6, and 5. So that this will come from plus 7 times 5, that's 35, minus 6, which is equals to plus 35 minus 6, that's 29. That's equals to 29. This helps you understand how to work with cofactor of a matrix. In case you have gray areas, please do not hesitate to use the comment section. We'll be there to respond to your questions. And finally, let's see the adjoint of a matrix. Now, for the adjoint of a matrix, the adjoint of a matrix is basically the transpose of the cofactor of the matrix. In case you missed a lesson where we explain the transpose of a matrix, kindly see the link here. I have placed a link here to help you access that lesson. Now, the adjoint of a matrix, like we said, the adjoint of a matrix is a transpose of the cofactor of that matrix. Let's take an example. If I have a matrix if I have matrix A with these elements and I'm to find the adjunct of this matrix, simply said, I am looking for the transpose of the cofactors of this matrix. First and foremost, let's get the cofactors of this matrix. Now the sign on 5 will be plus, here will be minus, plus, minus, plus, minus, plus, minus, and plus. The next thing we'll be doing is to find the cofactors of this matrix. Now, let's start with the first element, that's the cofactor of 5. My C5 will come from, now I'll pick this column and this row. So I have this element to come from plus the determinant of 1, 4, 6, 3. That's equals to 1, that's plus 1 times 3, that's 3 minus 24, which is equals to plus minus 21, which is equals to minus 21. The next element is 2. So we're finding the cofactor of 2. Now, the sign attached to 2 is negative. So it's on this row and here this column. So I have my elements 3, 4, 4, and 3. So that will be the same thing as minus into 3 times 3, that's 9, minus 16, which is equals to minus 9 minus 16, that's minus 7, which is equals to plus 7. Now let's pick the third element, that's the cofactor of 1, that will come from plus. Obviously, I'll pick, that will be 3, 1, 4, 6, which is equals to plus into 18 minus 4, which is plus into 14, which is equals to 14. Now we're finished with the first rule. Let's take the other rules. I've tried to repeat the matrix here for visibility sake. Now we're on the second rule. I think I missed an element. That's 4. We're on the second row, so that will be C3. I'm looking for the cofactor of 3. If you pick the cofactor of 3, is on the first row, on the second row, and on the first column. So that will be minus into 2, 1, 6, and 3. That will be the same thing as minus into 2 times 3, that's 6, minus 6. That's equals to 0. C1, that will be plus into 5, 3, 4. That's 5. Here is 1. Here is 1, not 3. Here is 4. And here is 3. Those are the elements. So that here will be 5 times 3 will be 15. That's plus 15 minus 4, which is equals to plus 9. Now C4, which will be that's on the third column and the second row. So that will be minus into 5, 2, 4, and 6. So that's equals to minus into 5 times 6, that's 30, minus 8, which is equals to minus 22. Now let's go to the last column, then we'll pick each of our elements. Now C of 4 will come from, not 4 is positive. I have as 2, 1, 1, and 4. So this will be the same thing as 2 times 4, that's plus 8 minus 2, which is equals to plus 6. And the next element is C of 6, which is equals to that negative, the determinant of 5, 1, 3, and 4. That's equals to minus 20 minus 3 is equals to minus 17. And C of 6, C of 3, 3 is the last element. That's in the third row and obviously also in the third column. So that will be plus 5, 2, 3, and 1. So that's equals to plus 5 times 1, that's 5, minus 6, which is equals to minus 1. Is equals to minus 1. Now with this, we have picked the cofactors of the matrix. Now we can arrange the cofactor of this matrix. Then we now take the transpose of the matrix. The cofactor of matrix A should look like, first row, we picked 21, minus 21, 7, and 14. That will be minus 21, 7, and 14. On the second row, we got 0, 9, and minus 22. That's 0, 9, and minus 22. And on the third row, we have plus 6, minus 17, and minus 1. Plus 6, minus 17, and minus 1. Now the next thing is now to find the adjoint of this matrix, which is equals to the adjoint of matrix A, which is the same thing as the transpose of the cofactor of this matrix. That will be equals to, now when we explained transpose of a matrix, remember we said the transpose of a matrix A is we actually turn the rows to the column and the columns become the rows. The same thing applies here. We now make the rows our column. The first column will be minus 21, 7, and 14. You observe that the first row has become my first column, and now my second column will be 0, 9, and minus 22, and the third column will be 6, minus 17, and minus 1. With this, we have been able to show how to find the transpose, the adjoint of a matrix, and we have seen how to find the minor of a matrix, the cofactor of a matrix, and also the adjoint of a matrix. In case you have questions, please do not hesitate to use the comment section where I will be there to respond to your enquiries. Thank you for staying with us, and we'll see you in our next class.